Hey there, everybody. Good morning. It is February 18th of 2025 here on a Tuesday. Oh, look at that. Music started back up because I didn't pause it. All right. Well, welcome to the Dev Talk Show. Rich, how is your Tuesday going?
Good. Off to a fun start. That's I don't know why I chuckle at that, but
I forgot to turn the loop off. Yep.
Well, I mean, some things loop, some things don't loop. You know, it's a lot for a Tuesday when you were off on a Monday.
Yeah, that's right. That's right. Well, so yes, that's
good.
right.
How are you doing?
Good. A lot of folks in the U.S. were. Some. It's not, a major holiday, but I think it is a federal holiday, so I'm pretty sure. Maybe, I didn't try going to the bank, so I don't know if they were closed, but President's Day was observed. Yeah, it was observed yesterday, and it's a day that most school students have off, and so on. So sometimes it's a busy travel weekend too. A lot of people, I think, take like a winter trip.
Yeah.
So in any case,
I never did the winter trips as a. I mean, much like you, I was traveling around playing hockey as a kid. So
yeah, so that was always a very well. Again, it was a tournament weekend. It's a very popular tournament weekend. So
yeah, definitely. As things kind of wrap up for the season, right?
Yep. So when we were here last time, we have been using or at least learning how to use AI models with .NET, C#, and the different options there. I think our goal is to build. I'm not sure what to call it exactly, but maybe an AI agent of some kind or multiple, just something that can be take maybe the place or do the same functions that like a producer of a show might do. And so the very first thing we were looking at was, given a prompt, can we get some show titles? Because maybe where we can get to is given a prompt, perhaps it can write out what you normally see in a YouTube description, the title and the description of the show, and perhaps if we could do things, and I mean, I'm kind of making features up. I know we've talked about a lot of them, but if we could feed it a show transcript, maybe it can produce. I don't know. Can it produce the chapters? Because it's really nice and convenient on YouTube when a show is maybe chaptered out and stuff like that. So
exactly, and I think that's when this kind of started. In my mind of, hey, there's a lot of stuff we do to kind of get ready. Maybe there's some things we can use for generative AI to kind of help us go down that path. And that's where this started from. But you're right, there's a whole bunch of things that we've certainly done shows in the past on about taking the transcript and doing something interesting with it. And, can we do those things? And maybe this becomes, instead of it being a console app, maybe it becomes something that's a little more, something up on a site that we both access, and whoever is putting the stuff in there or deciding on the show titles or whatever, and being able to store that content as it goes forward, right? I don't know all the features here, and that's kind of why, if I share my screen, let's see, we actually since the last show actually got it to a stable part, and we'll talk about how we got it stable and some of the changes that I did to it to make it work with the GitHub models, which is what we wanted to do the last show that we did, and just moved it up to the account that we have up in GitHub for the show. So it is. Does this still work? Let's see. Boop. Oh yeah, it still works. How about that?
nice.
So this is the application that, or the repo that we created, called it ShowRunner, and the reason is, some of the description there of, that showrunner in TV terminology being that person who produces everything and kind of gets everything in place and comes up with, even the scripts and things of that nature, right? All the production ready stuff is there. So, it was something that seemed appropriate. So that's what, sometimes we come up with these on our own, and maybe, the code name in this case is good enough to keep, and it becomes what we call it. So if we go into the repo here, this is, and it's public. Yeah, it is public. So feel free to as you can do in GitHub, make a copy of it, fork it, do pull requests against it. I think one of the things that we do want to do is maybe start to put some issues here and things that we want to do with this. And maybe we start there. Maybe we do the description bit and come back. But maybe we start there as we think about it. But the idea is, hey, we can go ahead and go down this path of building this out. And it's part for fun to show what's possible. It could actually be something, though, that takes hold and winds up becoming part of the process that we do here. But either way, it's open source. So it is there for you. I will say the description kind of came from a generative AI prompt that I did, I think just against Copilot, and give it some interesting content in here. So generating my README was pretty pretty efficient as far as timing goes, because it gave me some good suggestions here, and then I modified it a little bit, but for the most part, it's pretty close to what it gave. Feel free to interrupt and ask questions as I go through this. So,
well, last time I'm trying to remember where we left off, because I think it was a struggle to use GitHub models specifically.
Yeah,
and
that's a great
part of
segment.
what I struggle with is it seems like there are multiple, I don't know if I want to say SDKs, but that you can access these different, generative AI agents or models. You can do it differently. Like you can, one of the ways that I know you promote a lot is Semantic Kernel, but it's not the only way.
Right.
However, it seems to be the one that's trying to be more of a injectable framework, so that you write the code. You write the code, that the implementation once, and you only mess around with configuration to completely alter what it is you're talking to.
Yep.
Which is nice. I mean, that sounds very, very helpful. But in the end, I know it's been a struggle for me to understand like which one to use when, or should we be concentrating on one and wait. Well, I don't want to say wait, but like, you want to see everything, all the support coming towards it. But there was something about GitHub models, even though the APIs here say things like Azure OpenAI chat completion, and says, well, wait a second, is that something else? So
right. All good questions, and I'm I'm actually trying to wrap my head around those. I guess what I see is three major components. Right, there is things that you can get from the SDK, and I'm still, don't take this as full on truth. Yes, I work for Microsoft. I don't work for the product teams. So I'm trying to understand from the documentation and some of the examples I've seen and how I've used it, where I see these things kind of lie. So right. Now, this is, as of today, February 18th, this is kind of where I understand it. I know we have, as part of what I do, we talk to customers about what we, about AI and kind of where things are going. We have like a monthly session. I have one of those coming up, and I'm trying to put something together that talks through those various things, because if it's confusing for me, imagine, I'm hearing your thoughts and confusion as well, that, we need some way of kind of talking through those. So there is, I'm going to save Semantic Kernel till last for a second, just because of kind of the way I'm kind of thinking through these things. So there is certainly an Azure SDK, and that Azure SDK can be brought in, and there's, it is for many different languages. The SDK supports. Let me see if there's a way to maybe bring this up. Let's start there. So there's certainly an SDK for .NET, but we go here, right? So this is really focusing on .NET developers, which isn't what I wanted to do. I was looking for the more generic one, but the idea of, hey, if you're doing stuff in Azure, there's an SDK that lets you, or software developer kit, I believe is what that acronym,
Yeah.
falls back to, but essentially a way to bring some kind of a package or some kind of a reference to the service that you want to interact with and make it easy for you to code against that. Can you certainly do HTTP client and call against the management endpoints in Azure, doing all that securely? Sure. But there's a easier way to abstract all of that away from you and basically just talk to the SDK with the classes and the methods and all of the objects that it gives you. And I think that's where, for many people, that's where they might start talking to Azure services. But that means that the application I'm building is going to be locked into the specifics around that SDK. And that specific and that SDK has two sets of specifics. It's cloud specific in that it's Azure, and it's language specific in that it's C# or Java or Node or what have you, right?
Right.
And so it does very much, you're at the point you're trying to get started potentially, and maybe just trying to test something out. You are right now locking yourself into a platform and a language. Maybe what that may be okay, but it makes it tougher to move and talk to, especially when we think about AI models, be able to move off of that and be able to say, well, I need to bring in this model that's over here in sitting in the hugging face space, or something that might be over in something that might be more from an OLAMA that I'm running locally, right? Having that having that lock in there makes it more challenging to switch, where you might just makes it tougher to switch. So that's So think about it. So that's one piece I think of. Questions before I move on, because I don't want to just kind of railroad through it.
But yeah, no, I understand what you're saying, because I think you've seen, when I make the joke that friends don't let friends use the portal,
right?
That joke has a different purpose, which is to say, at some point as an organization or a team, you need to automate. And we're not talking about AI specifically at this point. We're talking about using Azure resources, which is if part of your workflow is your standard workflow, your deployment workflow is, we'll go to the portal and do this and make sure you click this button and make sure you choose this radio option. You're kind of asking for just a manual failure in missing a checkbox or forgetting a setting. And so folks who've watched this show or have probably seen, there have been times where I have gotten past the portal. I'll use the portal to learn, but then I'll go and I'll say, hey, I've got the command line to do this. And I'll even try to go one step further and say, can I lay in some environment variables and then pull them out of there? Because I'm kind of thinking down the road towards a DevOps perspective.
Right.
Using the Azure SDK to do the same things could solve a problem if what you're trying to do is programmatically automate, and you decide, instead of dropping to PowerShell, why don't we use something we're familiar with, which maybe you're a .NET developer. So you say, well, we could build this into a library. And that's all valuable. It's all valuable, right?
Yeah. And I think the SDK takes us kind of a step lower in that you've already got a service up and running, right? Or whether it's app service or Azure OpenAI or whatever it might be, you've got that service up and running, and I just need to communicate with it. There certainly is the CLI, Azure CLI, to get those services up and running and started. There is Terraform and Bicep as domain-specific languages to do those things, and those are typically related to the project that you're in, but sit outside of the source code. Whereas the SDK that we're talking about here is in your .NET application. So that program that we wrote, I think it actually has, if I'm not mistaken, we actually had to get, is it here? No. Okay, it isn't. And
so I don't want to get too sidetracked, because I think you're using the Azure SDK as it's an example. We have many ways to access Azure, and I wanted to point out that I often go to the CLI, but you could use Terraform, you could use Bicep, you could use this, you can use other things. And so that same confusion, or not confusion, but that same there's so much choice that I'm seeing, including when we were implementing some of this stuff, we were using things that I believe when we tried the first time to access the GitHub models using the sample code on GitHub, I think that it was using Azure AI Inference SDK. I think.
It was, yeah. Yep.
And so then you say, well, wait a second, what's the difference between that and semantic kernel and then this other thing? And that gets, I understand what GitHub Models is trying to do, I think, which is to say, as an alternative to Azure OpenAI Studio, or in fact, any other AI model deployment, because I don't know, I'm just going to be fair, I don't know how well this extends beyond Microsoft-owned clouds, like what's deployed on GitHub, what's deployed on Azure OpenAI. I just don't know that answer. So it sort of seems to be that, like most developers, I'm looking for, or beginning to ask myself, what's the path I should take so that I don't, like, we're all looking for this. What's the path I should take so that later I say, well, hold on, I want to switch to this thing. Oh, I got to rewrite the whole thing. Like, nobody ever wants to do that, right?
Nobody wants that. Exactly.
Yeah.
Exactly. And I think that's kind of why I started with the SDK bit, right? Because it is a bit of a lock-in, right? I know I want to run on Azure. I know I run in this language. And there are other SDKs. Like there's an AWS.NET SDK, right? Same thing, locked into a different cloud, but still locked into .NET. And so as we start to think, well, how can I'm just getting started. How do I do this so it makes things flexible for me? That's why I typically go the semantic kernel route. Semantic kernel is one of those. It's a bit of an orchestration language. It's a bit of a abstraction language in that it, from the C#.NET perspective, it is the only one that lets you bring it in and let you very easily switch between languages hosted in Azure, hosted in other cloud providers, hosted in things like Hugging Face, where models tend to live. You have this capability to basically switch things around where you want to run your app in, and it's just a matter of changing the method, and most of those methods have a similar signature to them, so you're not completely rewriting what's there. It's just a matter of swapping out that bit of a dependency there for that method that you're creating with the kernel. I mean, if we go back to our code, and
the other thing about semantic kernel that I think maybe differentiates it from some of the other SDKs is semantic kernel, number one, is open source, right?
Yes. There's a repo for it up on GitHub. Yep.
Right. So it's open source. I believe, I know we tend to use a lot of C# on this show because that's kind of our heritage, but I believe also has Python and Java support.
Yes.
And feels like, yeah.
And those are first class support, right? So as features are released, Java, C# and Python have essentially first class support for features as they come out for both of those. I'm not positive about the JavaScript side, but I believe it is that too.
Well, I think the three languages are Python, .NET, Java, not JavaScript. Yep. Which of course is easy to think like, well, everything has a JavaScript layer, right?
Yeah.
And we were concentrating on using .NET and building console apps just because you can kind of get going quickly. But I think I'm not saying I don't think I totally understand the value add, but I can see it. Like it's not totally obscure. I get that. Okay, here is a pathway that's being built that, again, number one, open source. Number two, use the language of your choosing. Many folks in AI like Python, and of course Java has a bunch of support too. But at the same time, it seems to also abstract talking to the models themselves, maybe. So that way I've abstracted it out to the action, which is I want to give a model of some kind of prompt. Well, instead of having to, well, here's how you do it for this, and here's how you do it for that, and here's how you do it for that, and I have to write all the implementations, it's more like, hold on, semantic kernel has that. You configure it to say, and you might have to configure it not just with the base NuGet package, but perhaps, and I could be wrong about this, but perhaps NuGet packages that drill in. And we see this pattern a lot in NuGet where you've got the base entity framework package, but now here's the one for SQL Server, here's the one for MySQL, because we're drilling into, we're closer and closer to where we want to land. I think semantic kernel follows that same model.
Yeah, absolutely. And
okay,
go ahead.
No, that was pretty much it, was just to say, so maybe there's a good metaphor for somebody who's watching the show and they're still easily, kind of get a little confused the way I am, is that think about how we do things if you're familiar with entity framework, in that it's one thing to take the EF core package. Now you also need the one, are you targeting SQL Server? Well, you need that. Are you targeting MySQL? You need that. Are you targeting SQLite? You need that. And whatever else is supported. and now you have the standard interface that gets you to the same place no matter what your target was.
Yes. Yeah. I think that's fair. And I think you're right around the semantic kernel giving you the ability to drill in and bring in additional features, right? And they're doing it in a way that's really interesting, where they I haven't run into this as much in other code bases, but in this code base, there's things that's like core to the application or to the project, to the open source project. But then there are things that are quote unquote experimental, right? We played around with Prompty and having Prompty be that component that does the system prompt and the user prompt for us that we send over to the LLM. Well, that whole feature, and having semantic kernel use that feature, is an experimental feature. So we had to put the pragma definitions in there, playing around with some of the agent stuff as I'm starting to look into that and understand, well, where does that fit into the picture, right? And having these autonomous bits of code talk to LLMs and potentially listen to events and or hear inputs from other or outputs from other LLM conversations and make judgments about them, right? All of those things are kind of in the space where an agent plays, that kind of sits outside of my code base. Even that capabilities right now is still experimental, as that gets settled from being in what was a research project to being something that's more on the production side when we think of semantic kernel. And those are all experimental as well. So they're doing it in the way that, okay, we've got base set of features, and if you're using those, things will, compile and be fine. If you're doing some of the experimental features, realize they're experimental and your code might change a little bit. So I think that's one of the more rich set of features from a package that I've seen in my experience in playing around with it. I just haven't come across that. I guess I don't come across that many things that aren't really production based at that point. But the other cool thing about semantic kernel is that of the orchestration pieces or the packages that you can use to talk to LLMs, it is the only one that has a C# interface, right? Or a C# package. Yes, it has Python and Java, and if you look at some of the other packages that are out there, there's another very popular one called LangChain, which is actually out before semantic kernel. LangChain talks Python, talks Java, and I believe it talks, maybe that's the one that talks JavaScript. But essentially, it's very popular. The Python folks, there's a lot of Python folks and projects I see where that's included, and it does the similar kind of things where it gives you the ability to get started and then make a switch to different models or even different hosting services for talking to those models. And that's kind of what you want, because most often, especially on the .NET side, writing AI into your application can be a new thing. And so you want to have that flexibility to, try stuff out and be able to not worry that you're going to hit a road that you've got to rewrite. But also, this whole space is changing so quickly in that, having the ability to go from a service that you're kind of aware of to maybe something that, hey, I'm just trying to test things out, and let's go the GitHub models route because it's not going to cost me anything, right? So having, that the space is evolving quickly enough that being able to have a language and a framework that gives you that flexibility is super important. So that's, I mean, for me, that's why I always defer to it.
Yeah.
Because
no, I understand.
90% of the time, the stuff does wind up in C# talking to Azure, right? But having the ability to showcase what's possible, that's why that's why I typically lean that way. Plus, there's a lot of things that are getting hooks into it. We saw with features that are getting released like prompting and agents, and being there in that space gives. It seems to be in the direction where we want to go from including these generative AI pieces in our application. So that's my thoughts around it. But the other piece that we haven't talked about is Microsoft Extensions.ai, right? Which is kind of a bit of a, I don't want to say middle ground, but let me see if I can make this do it without launching into a website here. Here we go. So this is a preview. That's not the one I want. That's the blog. Sorry, I should have had this one up and running.
Yeah, it's okay.
I'm looking specific for the Learn documentation because it does describe it a little better than just, here we go. So here we go, using extensions AI. So make this bigger. There we go. I think what's cool is that this visually helps to showcase kind of where things are happening, right? So yes, there is this extensions AI component, and if you read through the documentations, that extensions AI over time is going to be part of Semantic Kernel. And that's kind of interesting because when you think about what it is that the extensions AI does, you do get things like chat messages and interfaces of chat client and things that, well, if I've got it here in the extensions AI, why would I use Semantic Kernel? And I see this as a way to kind of get this kind of capability into the language and give a common platform for a package like Semantic Kernel to sit on top of. At least that's based on understanding how things are kind of being, how I'm seeing things as part of the documentation here. Again, I'm looking for something to kind of put all these things in different buckets and understand where things belong. So for me, this is how I'm kind of seeing the extensions AI bit. But I do think it's important. There might be applications where you might want to just go there. And I think we did that with some of the, with one of the examples we did with the GitHub models, where we were just opening a chat client. And we were basically saying, okay, just talk and just talk to the LLM using this instead of some kind of a larger framework.
So if you don't mind, that architecture rectangles,
yeah,
it's showing Microsoft.extensions.ai there, and whenever we draw these, sometimes it's never clear whether we should draw them top down or bottom up or whatever, but the application's
right
at the top.
Yep.
And the application is I'm going to use this terminology. It's using Microsoft.extensions.ai.
Mm-hmm.
And because it's on the same row, I'm presuming that what they're trying to tell us is that when you decide to take Microsoft.extensions.ai, you get access to Semantic Kernel, OpenAI, OLLAMA. It even says a little bit later in the documentation, it could be an OLLAMA, it could be something running locally, or it could be something running up in an Azure OpenAI deployment. It could be, who knows what it is, right? And it could be GitHub models, as it shows here on this chart. And so I'm giving you access to it, and in the end, providing you a chat client that just abstracts it all, so that you say, okay, chat client, here's your prompt. And I know it's unfortunate that the word chat is being used again, because it just leads back to that sort of, is that all we can do with AI is chat?
Right.
In some respects, I almost, maybe I'm wrong, but I almost wish it would have been like prompt client or something, just to sort of differentiate that, like, I might not get, this might not be a conversation. This might be, hey, prompt, give me, I could use a song that has these characteristics with these lyrics, and it says, okay, here's your audio, which those content types are mentioned on this picture here. So I'm trying to now, this is again, and I appreciate that you brought this up, but it's almost, I'm wondering if what you're telling us is, and you can sort of see it a little bit in the documentation table of contents on the left. We see that under AI frameworks and SDKs that we have Microsoft.Extensions AI, which I think is relatively new. I think it's like October of last year was kind of the time frame for it to be in preview, but we still have Semantic Kernel. And so, of course, you know what developers are going to say is, well, wait a second, should I be learning one or the other?
Yeah. And you even have this here, right? Which is, kind of where we started the conversation, right? Where you have SDKs against the AI apps, or in this case, SDKs for the OpenAI models. So having a language specific and hosting specific as well, because you have the Azure OpenAI and you have the OpenAI company SDKs as those.
Right. That table even sort of maybe lays it out, is you can use the OpenAI SDK, but kind of to your point earlier about Azure SDK is, if you choose the OpenAI SDK, what this table is telling me is, great, you can use OpenAI models. That separate company, right?
Yep.
But if you use the Azure OpenAI SDK, great, you can use models that you've deployed using Azure OpenAI Studio and that whole set of products. Or you can go up to Semantic Kernel and now you're abstracted.
Right, to go beyond, yes, obviously supported models is OpenAI and Azure OpenAI, but you do have, that flexibility to go beyond that as well. That's interesting. Yeah, so to go beyond just those services, right?
Yeah, right. Semantic Kernel goes beyond that.
Yeah. Now, some of those you can access through the Azure OpenAI instance, because there's like 1,800 plus models there for you to include in your application, depending what you're looking at. So even there, you don't, that you've got a variety of choice that probably can fit your needs, but if not, you have the capabilities to go beyond those.
So is it confusing maybe because, first of all, this space is newish, and it's confusing because you have a model, like we talk a lot about like GPT-4o or but there's where the model's deployed, and those are two different things.
Yeah.
And so now I've got this attempt to write SDKs and interfaces and to make life easier, but it's not all totally neat in that you always know that this particular model is always going to be in this place. That's not true. It could be through the Azure OpenAI. It could be through OpenAI, or I suppose, depending on what kind of compute you have or how complicated the model is, could be on your local machine. And Semantic Kernel is saying, I'm going to give you access to all of it.
Yeah, definitely. So that flexibility of that framework. And again, LangChain does something very similar, but there's not a C#.NET instance of that we can point to, right? It's Java's kind of if you think about the enterprise language, Java's kind of that option there. But I think you're spot on. So you could actually take, think about your development process. You might have, an OLlama. And OLlama is the containerization packaging for putting a model inside of a container and being able to access it. So yes, there are Llama models, which are created by Meta, that you can run inside of that OLlama container, but that's not the only ones, right? So Microsoft has their Phi series of models that are created by Microsoft Research. Those are small enough, they're actually called small language models, that
Right.
they can also be run in a container and run locally. So whether it's the Phi 3, which came out last year, and then the recent Phi 4, I think we're up to Phi 4 on that one. And that came out within the last, maybe the end of last year or beginning of this year.
I think that those are listed on this page too, but I'm not sure if you have to go up or down. There it is, right there. It developed with local models. You passed it right there.
There we go.
So like you said, it's talking about how those are a family of powerful small language models. And you said that, like, I'm sure, the documentation points out Olama because, like a lot of things in this space, some things just begin to be, everybody just immediately reaches for Olama, right?
Right.
But
because it's almost like Docker, right? It's that common, right? It's that common way of doing these things. And because of that, I can run Llama, I can run DeepSeek, I can run Phi 4, what have you, right? Locally. That's the important part. So it becomes that I don't want to say application, but it almost is, right? It's the SDK or the framework that lets you do those things.
Right. But then what you were saying is that you can use Olama to connect to local AI models with .NET.
Yeah.
But what some of those models are,
because of
Phi 3, Orca.
Yeah.
Okay. Interesting. Yeah. Like it's...
And then to confuse it, not to confuse it, but to add on to the functionality, right? There's the ability to essentially have connectors that talk to the vector databases. The vector database is important when you're trying to build a context for the language models to be able to base their response on. So we haven't done this in any of the examples we've done, but let's say we had, let's say we had all of our show transcripts in a vector database, which means we've sent them through an embedding process with a large language model. Well, what does that mean? So that means we take a transcript, and I'm going to do the 30-second version of this. You're going to take a long transcript, maybe it's 3 or 4 pages long, and you're going to break that up into blocks. Maybe it's, let's say it's 1,000 characters long, those blocks, 1,000 tokens long. Sorry, that's the right framework, right? Because everything we talk to LLMs is a token. And we're going to have 1,000 tokens, and we're going to basically send that off to the LLM and say, create a vectorized index of this content. And, we can think of vectors. We had vectors if you go back to, probably high school, where, vector is a direction in three-dimensional space. We can kind of think of it in 3 dimensions, right? And we can have that vector, maybe that length becomes almost a 4th dimension, because that gives us a sense of, well, how forceful is that direction when we think about things being pushed in a certain way. We can kind of wrap our heads around 3 or 4 dimensions, but these are tens of hundreds of dimensions, right? And because of that, we use some cosine capabilities and embedding capabilities to be able to take all of that textual token pieces and put it into something that is more geometry focused, for lack of a better term. And because of that, when I ask a question, my question can get turned into a vectorized component as well. And now I can compare the vector of my question to the vector of where that answer might reside inside of all of that vectorized indexing. And then once
I'm going to admit that. Oh, sorry. I was going to say I'm going to admit that the use of vector databases or vectors themselves for these applications escapes me. I understand what vectors are, especially partially coming a little bit from game development.
Right.
And I even think I get the base idea of saying, if we simply took semantic language tokens, maybe that's not a good term, and stuffed them in a database, that it just seems to me that would be incredibly slow to sort through this stuff in a text-based way. To say like, well, I'm trying to figure out what the next token is that's going to be in my answer, in my result. And so I understand, at least very, very high level conceptually, why wanting to turn this into a math problem makes sense. And I can only guess the reason vector databases are used would be to give, and this is probably a very simplistic explanation, but it seems to me that, okay, so why would I choose that? Well, now, because instead of trying to say, well, here's something that likely points to something else, you can give weight to that likelihood in a way that, because the vector has both a direction and a distance, or a weight in this case, so that, the longer the vector, quote unquote, perhaps that means it's more likely that the AI going down the path is like, well, 75% of the time I'm going to go this way. Now, I hesitate to say that I've explained it anyway how this works, so I want to be very careful there. But
right.
But I have noticed that in a lot of the samples that we have used, one of the first things it does, it says like, well, build the vector database, get that out on Postgres or something.
Yeah.
And I go, okay. and then it just does it. And then everything starts working. So you go like, all right, cool.
So let's take the example this way. So if we were to take all those transcripts that we had, right, and we just basically dropped them in a blob storage, and we had, AI search run over them. The way AI search used to work is it would just be keyword matching. So it would create an index, and you would basically say, well, tell us the show we talked about, Semantic Kernel, or the shows that we talked about, Hello Dolly, we talked about authentication, whatever topic we wanted to have. And it would do a keyword search against that. And that keyword search wouldn't be very specific, right? It might return a document of a transcript because we mentioned it in there, but it won't necessarily say, hey, where in that document were we doing it, unless we, took that and started, opened up the PDF and did a search against it. But that's a lot. You can certainly do that. But what happens is that's a lot of additional text that doesn't have potentially the context you're looking for to then give to the LLM to say, use this to base your answer on. And what we're doing is, by putting this vector index over top of it and doing this chunking procedure of saying, take 1,000 tokens and go have the LLM embed that bit of content, and then come back and then do the next 1,000 tokens. Now we're able to say, well, your question gives this vector representation that when I look at the various embedded various chunks of content that I've run embedding over, maps closest to these 3 bits of content. So now I've got a much smaller set of text that I can include in my prompt and say, base your answer on the content that sits here. And it's essentially the 3 pieces where it thought that our vector embedding matched up. That's why it's much more powerful, because not only have we not sent what potentially could have been 3 different documents, we're just sending roughly a paragraph or so's worth of material, 3 paragraphs or so worth of material over to the LLM and say, base your content on this. It makes the amount of tokens that get passed over much smaller, so you're not paying a lot for the LLM to do its work, plus a smaller content for the LLM tends to produce a better response than giving it a large document and say, find your answer in here.
I think, so this is a point where I'm going to just go ahead and say, it's already almost 10 till 8.
Wow.
9. I think this is a part where I'm going to say, I'm sure there's a way we can explore this part for maybe, would you say this like maybe for customized data, your own data store of some kind. But I'm still, it feels a little magical, but maybe it always will, because, there has to be there's a level of comfortability with anything we do where we just kind of say like, okay, I think I understand it enough. And that's why we have computers, is because they do these amazing things very fast and fill up big databases with stuff and blah, blah, blah. And so I remember we were working with something late last year where one of the first steps was to get a Postgres instance filled with a vector database and then everything started working, and I closed my eyes in that part and said like, okay, everything works.
Exactly.
Because I just, but maybe that's okay, because we
Yeah.
don't sit around wondering about the assembly code or even the IL code that we generate when we write code, and
Right.
it's becoming comfortable with this space, and I think it's hard.
Yeah.
It still feels like magic to type in a prompt and get an answer back and then wonder like, can I rely on this in an application? Am I going to get good answers back every time?
Right. And we still get those questions. And how can we, almost like the chemistry experiments, right? How do we, yes, the reaction takes this and leads to this. But if you add heat, you can drive that reaction much more to the right than, the small amounts that you might get without heat. And that's kind of what we're trying to do here. How can we drive that response from the LLM and generative AI so that it gives us a reproducible answer? And there are, I'm not going to go into it here based on the time of the show, but there are things that we might try and do to test some things out and say, okay, we've, with the thing that we did last week around creating a title, we asked it to give us 5 titles, and maybe those were fine, but maybe we swap out the model and then we run that again and we compare that to what we ran the first time. Those are things that we can do that kind of force us down that path of, hey, we're making improvements, not only in the making improvements in the result but doing it in a way that's testable, essentially. And there, we can talk through that at some point if that is something that we want to go down. But there are ways to force the output in the right direction, basically. You mentioned there's you mentioned magic, right? And isn't there a quote by a famous author?
Oh gosh, yeah, Arthur Clarke's very famous quote, right?
Yeah, which I can't recall, but it's basically advanced technology and magic are similar, basically.
Yeah, Arthur C. Clarke is very famous for having said that any sufficiently advanced technology is indistinguishable from magic.
There you go.
And it turns out that I have used that quote in developing games maybe more than I have when it comes to software, because sometimes what you can do, a trick you can use if you want to say, hey, I want to have you to have the ability to do something, but that seems a little bit like a magic spell. Like if you were playing a fantasy game, you say, well, whatever, just turn it into a technology. Yeah. Just call it an advanced technology. It does the same exact thing, but you just, instead of it being, hocus pocus and reading a scroll, instead it's a device, and the device makes the same thing happen. And you say like, yeah, I mean, it's the difference between, I think, The Incredibles having some freeze ray versus just having somebody use their fingers and wave a magic wand and freeze something. What's the difference, right? So that's, I think, what he was saying. And I think it was a guide maybe for, I don't know. I'm curious as to why. I know it's something that he was, I believe, published in a magazine in the 60s, talking about how when some new advanced thing comes to society, it seems you just don't understand it.
Yeah. I mean, I some of the things that I've asked generative AI over time, and the results it's given me have said, it's just magic. It just works, right?
Sure. And we use that term in computer science a lot. Like, sure. It's funny to see how it goes both directions, where if you've been doing this long enough, there were certainly aspects of, if you have been a developer on Microsoft products long enough, then file new project is a age-old term. And certainly there was file new project that we did either at the beginning of .NET or even back in VB, that a lot of stuff happened for you that you were never going to get to dig past.
Yeah.
But then at the same time, I think we also work the other direction too. When you look at something, in my opinion, I know we're not talking about AI anymore, but when you look at something like a .NET Aspire, .NET Aspire is
Yeah.
actually trying, I think, trying to push the other direction to say it should be very clear what we're doing with very readable code that you look at and you say, I know exactly what this distributed application is going to do.
Right.
Where if you kind of got it working the other way, it was like, well, I went and changed some settings in Visual Studio, and then I did some other thing here, and I changed my build file, and it's like, what is all that doing? I don't know, but it got me to where I could bring up the 3 apps and debug them all together. So I feel like it's really interesting how we push in both directions. We create new abstractions that feel very magical, but then we say, now how can we present them in a way that you understand what's happening?
Yep. Yeah. Although the first time I saw it work is like, that's so cool.
Oh yeah, you see, that's cool, right?
And, yeah.
No, I agree.
I know we're at 9:00. Do we want to take 2 minutes and just show that, just to kind of, we ran up going down what I thought was a good discussion. Hopefully you all feel that way out there as well. I'd love to hear your comments about it and kind of what you're doing around the AI space and how you're getting your project started. Are you going with an SDK against a service, or are you trying to do something like Semantic Kernel or LangChain to kind of make things a little more flexible for you? But if I go to here, so this is our, we created this, well, that's a title service. I want this one. Oh, that is it, Title SDK, sorry.
Yep.
So Title SDK, which is the class that got created for creating titles and talking semantic kernel. I have, this feels like the wrong one. 1 second. Because that's the one that's got those things in it. Hang on. If I do this, there we go. Content generator. I think that's what we called it, not title generator. We got a program. Yeah, this is better. It's a lot. It's flatter.
Okay.
We didn't play around with the way where things are.
Yeah, maybe just zoom in just a touch.
Yeah, definitely. So let me close this. There we go. I don't have to worry about closing the region anymore because my token is hidden. It's in my environment variables. We're not using the key, which is what we originally had in there from the service. So the point of what we were trying to get to is, yes, we got this to talk to Azure OpenAI service, and what we wanted to do was to basically revert things back and talk to this endpoint, which is where the GitHub models are essentially stored, using GPT-4o, and then also using our GitHub token, right? So not anything specifically in Azure, even though that's where they're hosted. But in order to be able to access that, we had to create this piece here, which is it's an Azure OpenAI client. And that client gives us a way of essentially communicating with that service. Well, how do we communicate with that service? Well, we need to provide it essentially, a URI, which is the endpoint that we've got there. And then we need to find some way to give it an Azure key credential. And that GitHub personal access token, which we generated a couple shows ago, is something that we can essentially use to create that credential with. Because we're talking to the models inference AI. If we were talking to our regular Azure OpenAI service, that key, that personal access token won't work because it needs the regular API key that is in that service essentially. So by setting this up, we wind up getting a client, and then that client winds up getting included now here when we do the chat completion. So instead of specifying the things that Semantic Kernel was looking for when we look at possible ways of making a connection, in this case, we're using, our deployment name, which we have is GPT-4o, and then this AI client, which is an optional item, but we're just basically throwing that in there because that's how we're making a secure connection to that, as opposed to this way, which is, the deployment name, the string endpoint, and the API key, which is how we often talk to the Azure OpenAI service. So having those 3 pieces there. So because we don't have an API key, we create a client, and then that client winds up being injected here. And then once we do that, everything runs. So run debug.
Did you accidentally like see that right there? Do you feel like maybe something accidentally got like accidentally a space bar or something? I was going to say, I wonder if you control Z'd it,
Right. Could I just make it work?
Yeah.
Maybe this does it. Yeah, because those problems are just warnings. There we go. So now we get this, and I could say, hey, a show about it's going to do that. And this one's good because it gives us 5 titles as opposed to just the one that my prototype did that we wound up showing last time on the show. And then we can basically choose one of those. It seems to be, some term, colon, and then some other phrase essentially. So yeah, and that, again, that's going against the GitHub repository as opposed to Azure OpenAI, which is how we got it working last time. So.
Okay, so that's out there right now. The Dev Talk Show is on GitHub, github.com/TheDevTalkShow, and the project is called ShowRunner, and it is out there today. So basically, the difference is you have to go to github.com/models and read. It doesn't seem that difficult about how to generate your own personal access token, and you have that set as a secret. So a user secret using the .NET user secrets feature.
Yep.
And that basically, once you've done that,
variables.
Oh, okay.
But same thing. It just depends how you reference it in your code.
Okay.
But yeah, you can go out and give it a try. Definitely would, check out the models if you haven't. And I think one of the features, I don't think I've seen this anywhere else, which is that compare feature of, hey, let's go ahead and use this and compare it to 5.4 model, and then I can ask the same question of both at the same time, which I think is pretty cool.
Cool. Awesome. All right.
So we ran a little long. Sorry, folks.
Yep. Yeah, I do have to get moving here.
Okay.
But in any case, it'll be interesting to see if we can use this to generate our next show title, which hopefully will be later in the week. I know for sure that I cannot tomorrow morning, but
okay,
we'll go from there. So, well, thank you, Rich. Like I said, I know I ask a lot of the questions and even the same ones, but I think we're in an interesting time where it's not even really hard to do a lot of these quick starts, but then you finish them and you say like, okay, well, now what do I do? What do I do next?
Right.
Hey,
it worked. Now what?
Yeah. Now what? And how does this help me? And what's this going to do for my application? So hopefully I hope that anybody watching, I hope you had some of the same questions and that we got some answers. And if so, let us know in the comments, or if you have questions of your own, do the same thing on youtube.com/TheDevTalkShow. So, all right.
Cool.
Get set up to
Thanks,
get out of here. No, thank you very much. I feel like there's some analogies that are starting to click for me. So
that's awesome.
The difference between models and where it's deployed and, using these different SDKs, but then I'm still trying to fit in what Prompty is doing. It's awesome. But I feel like it's even trying to fit in a way to say, hey, you don't have to write the code to do this. I know how to do that part. So you just define it in a text file in a standard format, kind of like a DSL, I guess. A specification is really what it seems to be.
Sure.
And then you're good. And I suppose as a developer, you could have several of these specifications and just pick the one you want at one runtime, I guess. I don't see why that wouldn't work. So I don't know if that's the way you'd want to use it, but you could.
Yeah, and I've gone down that That's an awesome conversation to explore, because I've gone through that in my own mind as well, and why you would and why you wouldn't, right? Because in the end, the LLM has no memory. So if I come to it fresh and give it a title prompt and then come back and ask that same model or do that same process with a different prompt, I'm going to get, a response that's geared towards that prompt. And so why do I have different, is that enough, or do I need to maybe think about them being different, completely different separated bits of code that run each with their own prompt?
Yeah. All right.
So you put the quarter in.
No, it's okay. All right. Let's see here. Do I have everything set up? I do. Okay. So everybody,
Cool.
If you made it to the end, thank you very much. Thanks for watching. Please be sure to hit the like button if you like the topic, and give us some comments if there's something else you want us to talk about. Other than that, Rich, for Rich, I'm Chris, and we will see you all next time on the Dev Talk Show. Oops.